auth, right? There's two different, there's two different words that I refer to when I talk about auth. The first one is authorization, and the second one is authentication. Can anyone tell me what the difference is or what either of them mean? When I'm like auth, like what am I saying, or what is it that it really means?
Authentication is confirming that the user is who they say they are. Authorization is giving them permissions to do what they're allowed to do given them being authenticated.
Cool. Did anyone else hear that? You heard that? Omar, cool? Cool. All right. So to just further elaborate a little bit, right? Is this GIF distracting? Sorry. When we talk about authentication, it's simply, are you who you say you are, right? So like, let's just say you're at TSA and you've bought this ticket for somebody named Roger, right? If I walk up and I'm like, yo, that's me, I'm Roger, let's get on the plane to the Bahamas, right? Because that's where you want to go. Cool. And I think it's going to be like, yup, absolutely. And just like, here you go. Good to go. Yes? Wow. A lot of things have changed since 9/11, let me tell you. A lot of things. But what they're going to do is they're going to look at either your passport or your driver's license, because that's a credible source that says that this picture has been independently verified, that claims that you are who you say you are, right? So I'm going to show up with this like uggo of a mug, and I'm going to be like, I'm Roger, and I'm going to show them a driver's license that says Wangtron, and they're going to be like, no, sorry, back to the line, right? And so really what it's doing is just, I want to make sure you are who you say you are. And so normally what we do online is we do some sort of username or a password. And so my username, I'm going to type in my username. The only way that I can actually prove that I am who I say I am is if I've given this secret password, this secret key, this secret word that only I should know about, right? We have like this handshake agreement, right? So when I make my user account like duck sauce and then my password is like 1234, which it definitely is. Please don't try to hack all my stuff. It's a terrible password, don't use that. Then yes, only I should know about that password, right? So what is authorization then? Let's go back to this like airplane example, right?
Privileges, so maybe like first class for your economy.
Yes, what it is that you are authorized to do. So even if I say, hey, I'm Evans, here's my passport, great, I have now authenticated who you are. Can I get on any plane I want? No. What am I authorized to be on? I'm now only authorized to be on that one bird that's taking out of that one airport to one destination. All right? So authentication and authorization. Most of this lecture is just going to talk about which one do you think? Which one should come first? Authentication, right? And then we're just going to wire it up to make sure that we can then execute the authentication and then authorize whoever's logged in to do what we say that that person can do, right? Because you can imagine that in your application, do you want your user to be able to do everything or maybe some things? Like for example, like I'm user 1, I'm logged in. Should I be able to see what user 2 is doing? Maybe. Should I be able to edit all the data for user 2 as user 1? Probably not, right? A little sketch, right? So I need you to prove to me who you are so that I can now give you certain authorizations to do certain things. Cool? Any questions on authentication, authorization, and auth? This class is very exciting. Cool. So what we want to do is we want to be able to have that handshake agreement for username and password, right? Yes? Cool. So Do we want to store these username and passwords as these plain text objects? Should we store the username as like a plain text object? All right, like if I'm like, oh, hey, my handle on GitHub is Wangtron. Should that be like a secret in my database? Username's probably all right, right? Like just stored right as a string, no big deal. That's not the secret information. That's not the secret handshake. It's not the secret key that I'm like saying is like the way to authenticate me, right? Should I store the password as like a plain text string? So like in theory, right? Let's just say I'm doing something like this, right? I'm just gonna get right into, my Rails console. Should I be able to do something like user.create and then just like name, right? Something cool. Can you see this? Right? All right, I'm just gonna do this anyway. Password, and then just like save plain text password, just like this. My database, should it say this exact thing? So if my database ever gets hacked, right, everyone could just read the username and passwords. That's not great. And while we tell you all the time, hey, shouldn't use the same password for your email, for your GitHub, for your Google, for your Gmail, for all that, some people do, right? It's bad practice. Because if you lose your password, if it gets hacked on some sketch website, you've now given everyone the keys to the kingdom. They can log in with your obvious like plain text username or email address and the same password you use for everything. It's probably a bad idea, you know? Probably a bad idea. You know what I'm saying? So just think about like your security, but also like you shouldn't be storing it. So what we need is some way to hashify our string, right? Does anyone know what like hashing or hashifying means? Yeah? It's like an algorithm that encrypts data. Oh, I love this game. Keep going. In a hash? Not in a hash, no.
Turns a string into another like non-human readable string according to some algorithm.
That's exactly right. When I hashify something, I want to be able to return in the same way that my cookies look non-human readable because it has very secret important data that you might not like know about in terms of like losing your cookie to a hacker and how that could possibly compromise your data, you know, and show you any of that. But that's definitely what can happen.
That's how like hacking Facebook, right? Like when someone like messages you with a link because they got hacked.
Yes, yeah, that's kind of what's going on. They get hacked and then there's like a bot that runs through like all your friends and sends a message that says like, hey, click on this link. Because that link is what? It's probably just a post to the hacker server that's pulling your username and password or sending the cookies over. Yeah, right? Because remember, cookies are passed on every request. So once I get that cookie, I can potentially do something with it. What? Who knows? Who knows? Bad things, I guess. Either way, the point is, I want to be able to, all right, let's take a look at that hierarchy. Boop, boop, boop. I want to be able to take something like, okay, right? And then I want it converted to something like this, right? So that like nobody really knows what that is. Does that make sense? So then I can store this in my database, and that would be considered safe. The important thing about this is that I need to store this in the database, this like ridiculous string, this hashified string, but I still need it to recognize okay. That becomes like a monster challenge. Like, how can I get this hashified string to recognize okay. It almost implies that this algorithm that takes okay to make it something bizarre is somewhat reversible, right? Like, I need a way to be able to break this back into okay. Does that make sense? In order to check against it. So like, if I had this saved inside my database, and I can be like, hey, listen, is this person's password, which is blah, 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 equal to what the user input inside the form that said, hey, here's the password. The user just put in okay. Does it match? Does that make sense? So the problem is, if it's reversible and I have this, why can't I just reverse it to get okay? Now I actually have a human readable version of your password if I can reverse it. It becomes really tricky, right? So here's the deal. There's something, and this is the first time you'll encounter this, but I promise you it will not be the last time. I'm going to explain a concept to you. I'm going to explain what it's doing, but I cannot explain to you how it's doing it. You need to be okay with this, all right? And the reason I'm explaining to you right up front that I don't know how it's doing is because if I did, I would probably be very, very, very rich. Yeah. So there's this idea, right, that like, let's just take a meat grinder, for example, right? I could put like a cow in there, like an entire cow, because that's how it works, right? Just forget the leather, hooves and all, right? And I just put it through this meat grinder. I could see there's some vegetarians in there. So I'm taking these like celery stalks, right? And I'm putting it inside this like vegetable grinder, right? That's how things work. And I have like this mush at the end, right? Do I immediately recognize, oh, that's celery, obviously. Can you recognize immediately after this vegetable grinder that that in fact is celery? What if I also put broccoli in there? Would you be able to recognize, oh, that's celery and broccoli? And it's definitely not kale. Kale is not in there at all. Could you recognize it? Probably not, right? So I've hashified this vegetable. But can I take a piece of it and test it for its like DNA and find out that it is in fact, some of it is part spinach, some of it's part kale, some of it's part celery? Can I do that? Probably, right? Can I ever put it back inside the vegetable grinder to get like a whole perfect looking vegetable? No, right? That's a little weird. The image I'm trying to get you to get is that it's a one-way transformation, right? I cannot send it back and retransform it into the original state. But I can check and verify if its contents match the original state. Does that make sense? So in that physical world analogy, somebody, like I think a bunch of MIT graduates and someone from Stanford or something, created this algorithm that is a one-way hashing algorithm that could still verify the contents of what the original string is, but will spit you back something like a mashed up vegetable, a hashed string. So let's see that in action, right? There's something, it's a gem, right? Magical gem. It's called bcrypt. Cool. So I'm just in IRB, so I'll have to require this gem. I've already installed it. So once I require it, it says true, and I have access to it now. Now I have access to the contents. Oh, I can't spell. Somebody spelled Distory, like on their code. And I was like, someone's been paying attention in lecture. So I now have access to this constant, right? It will also tell you that a namespace within this constant is something called password, right? And I can now create using plain text passwords. Like what's like a, you know what, I'm not even gonna ask you for a password because it's setting you all up for failure. Let's actually do this instead. Common passwords. right? Great. Password. So good. These are truly terrible. Let's just have a couple of laughs here, right? 11111, 777. Okay, cool. My noob, number 12. Great. Congratulations, right? Sweet. So back to here. I can put my noob, and what I'm looking for is like some non-human readable string. So I get this. Whoa, that's weird. It looking like a weirdo, right? What is this? Interesting. Interesting. So, if I had this, right, could I then go back and recreate it? Can I turn this back into my noob? With bcrypt, you cannot, right? It does not go backwards, which is like insanely difficult to try to comprehend how that works under the hood. I'm just telling you what it's doing and that it works, right? Bcrypt has been the standard for like cybersecurity, and anyone worth their weight as like a security engineer will tell you that bcrypt has not been broken. Cool. So that being said, let's check out a couple things, right? First thing I want to think about is, if I have this, right, can I maybe figure out that anyone with this exact string probably has a password of my noob, right? Because I can check against it. Does that make sense? Like, I should be able to compare this random string to my noob, and it should be good to go, right? Let's check, all right? So I can just do bcrypt password, right? And I'll tell you what .new does in a little bit. And it takes in this hashified string object, bloop, bloop. I might just zoom out a little bit. And I want to double check it against my noob, right? I want to make sure, like, hey, when I take this string back, right, I want some way, I want some DNA extraction to find out, hey, did it come from my noob? Does that make sense? What should I get? Just kidding. I spelled it wrong. Ruined the effect altogether. Why am I? CRYP. Yeah, there we go. Cool. Cool. Cool, 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 cool. Right? So true. Interesting. Let's just double check it against my newbie. Right?
So this isn't a true random.
It's, yeah, so I want to assert and test to see, hey, does it just return true for everything? Right? False. Cool. What about very popular passwords like password? Or my password, my personal password. Cool. Right? So it's actually checking to see if it matches the original. So far, so good?
There are like a couple of cases where like it will match with something else, right?
The odds of that are so astronomically low that it's considered secure. Yeah. In the same way that like I can put a deadbolt on my door and it's considered secure, but if I had like dynamite and I literally physically blew away your door, I mean, I could get in the door, right? It's not like impossible, but the odds are so low. Cool? All right, so that being said, this must mean that this hashified string is directly related to my noob. Does that make sense? Like that string is related to my noob because I can check against it to see if it's like, hey, does it equal this? Right?
So like, if you had another one, I do again, like multiple users have to have the same or different passwords because of this.
Interesting, right? The theory now becomes, what if other people had a common password like 1234? Would this string come out exactly the same? Because I'm just comparing it, right?
Does that imply that like the algorithm is like specific to?
Well, the salt can be different.
Okay, cool. So, if I run this, right, who thinks that I'm going to get the exact same random string that comes out? All right, cool, let's check. Are they the same? No. So how does this get achieved? So, if I take the exact same input, right, I must add a little bit of flavor to it, like a secret little piece of data, probably random data, that now I can in fact hashify it with, right? So like not only do I put in my noob, I'm also going to put in my noob PL, right? I'm just secretly add something in, right? Just like a little bit of extra data, just so that it doesn't come back exactly the same every single time, right? Yes?
So it's kind of like having like a puzzle that you break it apart and spread it around. And then if you take the same puzzle several times and spread it around, it's not going to look the same in the mess. It's just going to be like...
If that's the way you want to think about it, you can think about it like that, but it's also like, in that same analogy, if I had a puzzle piece and I break it down, I also add in a bunch of extra puzzle pieces and I mix it up. And I add in a bunch of random puzzle pieces every single time so that it's really, really different.
The only thing I know, and it knows it because it's witness to it. It scrambled it itself, so it's witness
Sure.
to it. I don't know.
Sure. I don't want to like confuse anyone else, but if that makes sense in your mind, then go for it, right? So this extra little secret data that I add to my password, my noob, is known as a salt, right? S-A-L-T, right? So I don't want you to think that I'm talking about like assault, you know what I mean? This is a crime. That's bad. I don't teach that here, right? It's assault, this thing right here, right? I made a really bad joke earlier, but nobody caught it. I want to add a little flavor, right? There we go. I want to add a little flavor to my password. Cool? So this salt is randomized, and it sprinkles in with my password to create some random level of data. And that's why it's really difficult to kind of break this, because you would need the salt and the string to basically be able to double check. All right? Cool? Any questions so far on just bcrypt being able to check and seeing what's going on? Yeah?
When you said you added like a little PL in the string, you're saying like bcrypt?
Bcrypt will do that for you, yeah.
Yeah.
Not me. That would be crazy. Because like I would never remember. You know? So that being said, what I want to check, right, is do you remember we did? Oh, I ran this command too many times. Here we go. My noob, right? And that came out true. Interestingly enough, if I were to just do this and do this, would that work? Oh, sorry. That'll definitely not work. What about this? Just kidding. How's that? Why would this not work? This is literally just regular old string comparison, right? Not to confuse you or trick you, but okay probably doesn't equal to not okay, right? It's just pretty standard string comparison. So here's what my Asian is coming out. Here's what bcrypt is doing under the hood, right? Besides these truly terrible passwords. So we have bcrypt, right? Excuse me. In it, the namespace is class password. Do you remember this from inheritance a little bit? Right? You just have a module here, then you have a class called password, and it inherits from what? String, right? So what I could do is, this is just a fancy way of calling like class methods, right? Instead of like in your class, you would do like def self dot some class method. If you put something like this, everything here and forever will be like class methods. Cool? Just like a shorthand. So it looks like if I go through this, it overwrites the double equals. This is known as monkey patching. Do you remember this from Mod 1? All right, so like really, really fast, all right? If I were to do something like 1, and I were to call like 2s on it, it would make it a string. But then I can easily go right into the string class and be like, haha, just kidding. Actually, I want this method called 2s to return 99 for no reason, because it's hilarious. And now I can do, I don't know, like okay, and I can call 2s to it, and I should just get 99. I've just like overrid it. That's not a good way. I overwrote the 2s method, right? I can do that. It's called monkey patching. Yeah? So they're overriding, because they inherited from the string class, and now they're writing their own double equals, right? It takes in a secret, the hashified string, and then it will run, right, super, like a parent level method, take the secret and the salt, and it will compare it to the string that you're checking against. Cool? Did I lose anybody on what is happening here so far? You don't have to understand this. You just simply have to understand that it's overriding the double equals. So, in the same way, right? What is the class for this? It's a bcrypt password object. So when I run double equals, am I running the string double equals? Oh man, that's embarrassing. Am I running the string double equals, or am I running the bcrypt double equals? Cool, 3 people get it, that's fine, right? I'm running the, oh, yeah, sorry. I'm running the bcrypt double equals method, right? Any questions so far? Sorry, I just did something stupid. All right. Do you see how this could be potentially useful for, if I have this stringified, right, this hashed object, I can now save that hash into my database, check the bcrypt with that hash, and then compare it to what the user puts in as like the plain text password, right? So let's actually write some code then, yeah? Cool. So back to this. All right, this is a very, very detailed, like, Andrew, the previous like Mod 2 instructor, wrote these like dissertations on a lot of these things, and the student-facing readmes are just fantastic, right? It takes you like start to finish. So we're gonna go over just part 1 today, and then I'll finish part 2 for you. But I will upload this code so that you can at least follow along the readme. So tomorrow you'll be able to just like zoom through and understand. And if you really wanted to try to get authorization and authentication and like a login working for your app, the readme will take you through it, but I will still lecture you on it so that you could see it in one coherent thought. Is that okay? Cool. So I have in my users controller, right, create. Looks pretty normal. Yeah.
Sorry. So if someone was to hack the database and then they get all of those long, hash things, right? If they were to plug those hashes into like a password field, would that work on a website, or is there you have to set conditions?
We'll set conditions against it. Yeah. There's also something called rainbow tables for security, where like if I have all of these hash passwords, right, I can just run them against the top 100,000 most common passwords, and eventually something will hit, right? Does that make sense? Like if I do wind up stealing a database and I have 100,000 users, I will get all of these hashed strings. I could take all of them, run a .each, right, call the password, and then compare it to an array of like the 100,000 most common passwords and just see which one hits true. So like don't use passwords like 1, 2, 3, 4, you know? Even if your data and your password is encrypted, people will do things like that. So that's why your password should be something unique, like Alan Turing is the best, but you spelled the with 3. I don't know. You know, I don't know. I don't know what your password is, and I'm not going to guess. That would be bad. So I have like a user create, pretty normal, right? I have in my users model, oops. All right, these are just like an old project. I just needed something to like get spun up already with like a form and stuff. And in my users, I have a form. Cool? All right, this is just my error message handling. This is my form 4, right? Because I have a username, I have a password, I have a profile photo. Questions on this? All right, let's take a look at that schema. In my users, I have a username, something called password digest, and just like my profile, right? Why would I want something like password digest in my schema, in my migration, and not something like just the password here? Sure.
Just in case someone gets access to the database.
Okay. Right. This is pretty good responses, right? What I'm looking for here is after I run it through bcrypt, it has just been passed through that vegetable grinder, right? It's been digested and processed through something, so it's now hashified, because I should never store the plain text in there, exactly like you said, right? For security. So I needed like a more unique column name in here instead of just password, so that I can identify that, hey, this has just been digested, and this will come into play a little bit later. But that's like the idea here so far, right? So naturally, in my form, who remembers what's going to happen in my form 4? What does this do? What will text field do with this symbol password? That's right. It will call .password on the user. Right? Do you remember this? Right? So if it's going to do that, and I don't have .password, what should I expect to see in my browser? Yes, an error, specifically the error that says, hey, there's no undefined method password for user object. Is there any questions on where that came from or why that might be? Cool. Rols. Lol. Lol. How do I get to that user? How do I make a new one? User's new. As promised, undefined method password for this user. Did you mean, God, Rails is so smart. It's like looking under user, and it just found the first thing that kind of matched the password, and it's trying to help me out here. Did you mean password digest? No, Rails, I didn't. But thanks for trying, right? Any questions on why this error came up? Cool. So, what should I do then? I know. I'm going to go right into my user, and I'm going to make def password. And it's just going to return @password, right? That looks normal. And that should be okay, right? Let's find out. Come on, Rawls. Come on, Rawls. What's going on? Boom. Fixed, yeah? Any questions on like why that worked? Absolutely. Who remembers mod 1 when I was defining in my models things like def find all movies, something like that, all right? And then, because it was in my model, I can create a new user instance, and I can call the method .find all movies on my user, right? In the same way, I've literally defined a method called password. I'm returning the attribute or instance method, right, for password. And so I no longer got a undefined password method for user object. All right, back to mod 1. Cool? All right, so you see how this all like builds up, right? Mod 2, right? So, I can do username, right? Look at all these great username. Squirrel, cool. What about password? Ooh, Michael, that's a popular one. Why? I don't know. What happens when I create user? What should I do? What route does it hit, and what should it try to do? It's going to, right, post to users, and then what? Then it's going to what? Try to create a user, right? Absolutely. It's probably going to do something like def password equals, right? It's going to take in what? What from the user? Like a hashed password or a plain text password? It's probably going to take in the plain text password, right? Because so far I haven't done anything sexy with it yet. I haven't decryptified it. I haven't set it to my password digest. It's just right now an input that I've received through my params, right? So far, so good. So how can I hashify it? Dot create, cool. And I'm going to take in what? The plain text password, and I'm going to assign it what? All right, let's just put X for now because that means nothing. Let's drop a bybug. Cool. If I hit create user, I should hit this bybug because it's trying to update the attributes for my user, right? Remember, real quick, I'm running out of time, but here, password. Right? It's a form for user password. It's trying to update something called password field within my user. So it hit this bybug because it's trying to update the password. What do I have access here? What is self? Do you remember? Inside an instance variable, what is self? The user object, right? So username squirrel, password digest nil, because I haven't assigned it yet, right? And it's this user object. So do I have access to self.password digest? Yeah? Cool. Can I assign it anything? Like self.password digest equals to okay. Can I do that? Right? Probably. And so if I call password digest, it gives me okay. Knowing this and remembering this from mod 1, I can probably assign the password digest of this particular instance to my now hashified bcrypt password. So far, so good? So we don't need this bybug anymore, right? What can this do for me? Well, let's check to see if it even works, right? Boop, boop, boop. Let's just continue. Cool. Well, I have to make a new one, actually. Oh, God. Flavortown. Flavortown. I'm not going to spell that wrong and do my boy injustice. For now, the password is guy, you know, obviously. So if I hit create user, yes, I should see that when I insert into, right, I have a username of Flavortown, and my password digest is now this hashified object, which is secure, which is great, right? Cool. What else can we do? Let's think through this. What's going on now? After I've gotten this hashified object, what should I do? Okay. So now I need to create some sort of login page with this, right? Okay. You just want to Mm-hmm. Yep. So what would be really helpful, and this is just if I'm asking questions, instead of jumping 2-3 steps ahead and just saying words, if you want to help, finish the story. Because that's what's really helpful here, right? If I were just go make a password, encrypt it, authenticate, authorize, all right, log in, we're going to do sessions. That's not very helpful as much as it's like, I don't want to save plain text passwords in my database. How can I hashify them? Great, I have this gem. This is what it can do. Let's hashify. Let's see if we can store this hashified object into our database and then call it, right? So let's like finish the story. So I think it's really good. Just like we'll continue the story arc. Yeah? It's easier for you to follow a story, not just for learning, not because I just like telling stories, but because you will run into these problems, and that is the thought process that's happening, right? Like, oh man, I need to do this. Like, how can I do it? Like, let me go find something, right? As you like tell yourself this story, that's when you know what to Google, right? How can I not store plain text passwords in my database? That's literally what I would Google, that entire sentence, and bcrypt will come up. I'm like, great, how can I use bcrypt? And then I look through the documentation, right? And so that's why that's kind of like important, right? Cool. Because the labs will tell you in isolation, all right, cool, this is how we could do this. This is how we could do this. This is how we can do this. But until you've pieced the whole thing together, you can't really see how it all comes together, right? And so hopefully, like, that's like the goal for this, right? So what else can we do, right? And you're on the right path, so do you want to continue the story?
So now, we need to make some sort of way to verify that it's working the way it should be. It's the plain text password that the user enters matches up with the bcrypt password we just made.
Yes, absolutely, right? Now that I have this ability, right, and I have this password digest, we saw in the IRB that I can in fact use bcrypt to double check against the plain text password that my user will put in for login and verify if it's in fact the same as what I have in this hashified object in my database. Right? So I'm comparing what I have in my database, which is non-human readable, to a user input that says, hey, is the password matching? Right? Without revealing the secrets inside my database. Yeah? That's actually part 2, but what I want to show you is this is the problem that we sort of run into, right? Look at this guy. Flavor Town, right? If I were to like log in, right? Let me just do something like 22, right? Let's just say I'm logged in as 22, right? Should I be able to go see 20? Probably, right? Should I be able to edit 20 stuff? Like this, loser, ha 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 ha, right? And then I'm a great hacker and I go to 16 and I go, guess what? I know the URL for this because I understand RESTful routing. This guy also, loser2, ha 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 ha. I want to prevent this. I want to make sure that the authorization after authentication prevents me from doing anything that I don't want my users to do, right? So part 1 is just bcrypt and understanding that part, right? You guys want to be upset? I'm going to be upset a little bit, right? Cool. So let's make this authentication method, right? Cool. I can authenticate, right? This is just some method that runs authenticate. So ideally, at some point, I can do user.first.authenticate, right? That's like the goal for this, right? And so I'm just going to keep going until I kick me out, right? And it's going to take in what type of object? Let's think about it. The user is going to be giving me what? Plain text or hashified? Plain text, right? Plain text password. So I want to be able to run this method whenever I get the user's input, and I want to compare it to what? Bcrypt, right? Password. Dot new, right? New is going to do that magical comparison, right? I need to take in the hashified object. So again, how do I have access to it? It's in the password digest, right? Within the object. So I can do this, and I can, in fact, compare it to this plain text password that the user just passed in. Cool, right? So now I have the ability to do something like @user, right? When I make this instance of user in my view or something, I can always just do .authenticate all right, with what? The params of password. Because that's what's going to be coming in, remember? When you submit a form, it's like param something in the controller. So this is essentially what I'm trying to create. Cool, cool, cool. You want to be upset? Yeah. Cool. That's what all this does. No? Great. Automatic. Right? I mean, it doesn't actually do this, yeah, but you know what I mean, right? So you should have an authenticate method, right? It will read your password and it will overwrite your password using bcrypt every single time. Are there any questions to bcrypt and hashifying passwords and securely storing them inside your database? Great, that's part one for auth.